Is this thing on? Can you hear me? Is it coming through? Okay, good. I can't quite tell. My name's Lance Albertson. Thanks for coming in. I'm going to be talking about Packer today. Before I get started, I just want to thank our sponsors, because without them, Scale wouldn't happen. MaxCDN is a next-generation content delivery network based in Los Angeles. The whole team is obsessed with speed, automation, real-time reports, and implementation. If you want to put some bandwidth through their CDN, head over to maxcdn.com for a free trial. So that's the end of my spiel for that. Thanks for coming, even though I'm not Jono Bacon, so I'm not going to be talking about community, but that's cool. Yeah, Packer. Before I get started, how many of you have heard of Packer before you came here today? How many of you have never heard of it before? All right, got a mix of both. Cool. But before I get started, let me at least talk a little bit about who I am so you can understand why I'm talking about it. I'm the director at the Oregon State University Open Source Lab. We're based up in Corvallis, Oregon. We provide a lot of infrastructure hosting for many open source projects that you probably interact with daily. I just listed a few. The Linux Foundation is hosted there. The Python Software Foundation is hosted there. The Apache Software Foundation is hosted there. We do a lot of hosting for open source projects, and we interact with the community quite a bit. We've been around for just over 11 years, so I have a lot of experience. And by trade, I'm really an ops guy. Now I'm stuck in management, so. But I'm primarily a user of Packer. I have not developed directly on it, so if you're interested in that, I unfortunately can't help you with that. But I will tell you as a user what's awesome about Packer. So what is Packer? It's basically a machine image building tool. And it was created from the same guy that created Vagrant. How many of you have heard of Vagrant before? Hopefully a lot of you, yeah. So his problem was a lot of people were using Vagrant. There really wasn't a tool to make Vagrant boxes that easily. And then he kind of thought bigger. He's like, well, just outside of that, making images for all these various platforms kind of sucks. Either they're distro specific, so you have to learn this one for this distribution or this one for this one, or you have to have different configurations between all the various platforms. So he decided, let's fix this problem, and he created this project called Packer. It's written in Go, which makes things interesting, but overall it makes your life a lot easier. So it has a lot of platforms supported. When I first started using it, I think it maybe had 2. Now it has a lot more. I primarily use the QEMU platform for KVM support for building OpenStack images, but you can make this run on a lot of different platforms. So what is it actually trying to solve? So I'm not talking about the good old days about we make a golden image and we have to update that image and so forth. This is really about the cloud environment today. And images, at least in the cloud environment, are really nice because you're dealing with the cattle VMs. You want to be able to spin it up really quickly. You want to be able to have the software pre-installed on it really quickly. You don't want to have to go through the installation manually and everything. Maybe you want to have your configuration management pre-configured on it. And having one tool that you can have the same tool that builds your Vagrant boxes for your developers, that builds your EC2 images. It does the same thing. It's a whole stack. So you can have one configuration file or a couple that does everything. So if you're doing it in the cloud, yeah. If you want to do it in Vagrant, yeah. It even can build Docker images. I haven't personally done it, but I know you can do it. And really, it's designed to integrate into the whole cloud and DevOps model really, really nicely. You can integrate it in with Jenkins, doing your builds. Makes it really, really simple to update images, upload it, and do things as you want. And by the way, if anybody has any questions, feel free to interject at any time. I'm here to kind of answer that. So let's get over a little bit of terminology. I tried to keep this as simple as possible, but it's kind of important to know. So the core thing with Packer is templates. That's the configuration file. When you do a build with Packer, you type Packer build, and then you give it a JSON file that has the configuration. I'll show you an example of what that configuration file looks like, but it basically has all the information that Packer needs to know to build it. It doesn't maybe have the logic of the script. It doesn't have the scripts built into it, but you have the tools to write scripts to do things you want to do. The next layer down is builders. So builders are all those various platforms you see here. You have a builder for OpenStack, you have a builder for Docker, you have a builder for Google Compute Engine, and so forth. So, and within that, you can have build specifications. So maybe you have multiple builds of the same platform that have different configurations that you want to have. And the next layer is provisioners. So after you've gotten the base operating system installed or the image made, you probably want to do some steps to do things. Whether it's install, in the case of Vagrant boxes, you need to install VirtualBox drivers. Maybe you need to install the Vagrant user and put the SSH key in and give it put it in sudoers. Or if you're doing OpenStack, you need to install CloudIn it and get some of those other tools going. So provisioners can be, and I'll go in more detail later, but they can be shell, they can be configuration management tools. There's a lot of different things. And then there's post-processors. And those are basically actions that can optionally happen after the image has been built. An example is with Vagrant, it turns it into a Vagrant box file, which is portable. So those are kind of the 4 basic terms that you need to know in Packer. Read more about them on the Packer documentation site, but I want to give you some basics. So one of the things I've noticed is people really haven't understood what Packer does step by step, and once they see it in action, they kind of understand it better. So I tried to write this down, at least in an example form, so you can kind of see what happens in the process of making it, at least in the example of QEMU, how it builds an image. Inside of the definition file, you put in an ISO image, and Packer will automatically download that. You put the SHA in it, so it verifies it's the correct ISO. It creates the virtual machine, it creates the disks, then it starts it up. It boots it from the CD, the ISO image. Then you wait it. You have a certain wait time to wait for it to boot up, and this is the cool part, and I'll try and show it to you later. It'll use a library to literally connect to that VM using VNC and literally type on the keyboard to get it to do the automated kickstart install or pre-seed or whatever you want to do. And then you literally put things in like enter, and then it presses enter via VNC commands, and it boots it up and goes forward. And after that's happened, Packer actually starts a small little HTTP server that serves that kickstart file or pre-seed file, and it knows when that file's been downloaded. And when that's been downloaded, it switches to waiting for the SSH port to start. So it just sits there and waits and waits and waits, and you can have that configured to kind of go through it. After that, so during this whole process, the automated kickstart pre-seed stuff is happening. It's doing everything you want to do. And then usually in the pre-seed, you want to have it reboot. So it reboots it. It comes back up. SSH hopefully is working. And then it runs anything you have in your provisioner. So in a lot of cases I have, it uses shell. So I have scripts that run that do various tasks. So I'll show you in the config file, and you'll kind of cringe when you see it, but it literally takes the script, pipes it into the SSH command, and runs it through sudo on the VM to do it. It's kind of a crazy way of doing it, but hey, you're just building an image. So you do all those steps. You can set variables, environment variables inside of Packer. So maybe you want to have, you want to be able to adjust how it's built during that process, and it does all of that stuff. And then when it's done, it finishes, and you have an image file. In the case of QEMU, you have a QCal image. In the case of Vagrant boxes with the post processor, you'll have a .box file that has everything you need. It's really, really cool. When I first saw this, I was like, this is the coolest thing ever. Any questions about that process? I have, yeah. It's just built into the binary of Go, or in the Packer binary. So it just automatically sets it up. And I'll show you in the config here in a little bit. It automatically sets the port, and you basically tell Packer here is where the file is in the file system, and it does a relative pointing to it, and then it just makes an HTTP server that serves that file. Oh, yeah. I think you can do it with Windows. I haven't personally done much with it, but I think you can. Yeah.
With SSH, does it generate the keys on the fly, or does it do like Vagrant where it's got a default key?
Well, that's part of the kickstart image that you make. So when you initially create it, you have it using a password, and you have password logins to do it because you're just creating the image. And maybe one of the last scripts you have maybe sets it to turn that off. And so you can do whatever you need to do in that fashion.
I just thought that was a vulnerability to try to use the bigger things anywhere else.
Yeah, basically, yeah, totally. So variables in Packer are kind of weird when I first looked at it. Being a sysadmin, looking at JSON files is kind of weird. But here's an example I literally took off of the Packer documentation site, where here's a good AWS example where you have an access key and a secret key. You obviously don't want to save that into the template file. So what you do is you set the variables inside of the config file, and then you use them below using the Packer templating style to actually put that information in there. You can also set environment variables. So you use those variables to set environment variables, which are great if you're trying to use a single template file to build multiple things, but you only need in my case, there's some scripts that I always run the VM tools that install the VirtualBox drivers. But when I'm making an OpenStack VM, I don't need to do that. So there's a variable in there that says, hey, I'm not doing this, turn this off, and it does that. So you can set variables inside of the Packer, which is really, really nice and powerful. So kind of putting it all together, here's what it would look like. So when you're on the command line interface, you would type Packer build, you would type var, and then the name of the variable, and then point it to the JSON file. Or you can literally just put it in the JSON file and have it source that. So it's pretty simple. So what this really does is it really allows you to automate it a lot more easily, like using Jenkins or some other things you want to use to kind of get it going. So pretty cool. So here's how it works. Here's part of a config file. I couldn't get it all in one slide. And this is an example of one that I'm using. I'll actually show as a demo. So this section is the builders. You can have multiple builders. This only has one builder in it. Many of these settings are specific to QEMU builder. There are specific ones for each of those builders. So check the documentation for what builder you're using. So here we go. Here's the boot command. This is what it literally types into the VNC's console. So it hits tab, and then it types this in. These are variables that are internal to Packer. So it automatically sets the IP address, which is usually localhost, or no, it's one of the other IPs. Yeah. It literally starts a little HTTP. It's just simple HTTP get. There you go. And I'll show you in the file system. Basically, you have this file locally on a file system, and it just starts it up locally and just connects to it. Here I'm telling it KVM, tell it to wait about 10 seconds so it goes through the little emulated BIOS. I'm going to make a 2 gig disk. Headless mode is nice for automation. If you have headless mode off, which I'll show you, it'll literally open up the QEMU window that shows you everything booting up. But on a server, you typically probably don't need that. When you're debugging stuff, it's kind of nice to see. I have the HTTP directory actually literally called HTTP. So it looks in the HTTP directory for this file right here. And then I have the ISO checksum. I actually have the mir as a variable, so I can change it. I want to use my local mirs because we're awesome. And then here's literally the ISO I'm going to use to install. When it's done, it's going to create a directory called Packer CentOS 7, whatever I want to call it. And then here you can put an array using JSON, all of the QEMU args you want. So if you have special tweaks and things you want to put into the QEMU binary, you can do that. Really nice. I actually usually run this on a CentOS 7 machine, which has a different name for the QEMU binary. So it lets me change the name of the QEMU binary. And then this next line is what it runs to shut down the VM. One minor note, that's just that tick right there is to make my restructured text happy. Otherwise, Vim was getting pissed off with the highlighting in the rest of the file. So ignore that one little tick right there. But you can see where it literally goes in there and it types, it echoes CentOS, which is the name or the password for root on this VM by default, and then it halts it. And then for SSHing itself, here's where you define it. So you give it the password, the port, and the username, and how long it should wait for the SSH to go. Since I'm making OpenStack images, by default, it's the name of the distro, so CentOS. And the actual type is the QEMU builder type. That's actually the type that it's made. And then I can actually give the VM a name for itself, its host name. So I called it that. Any questions on this slide before I go to the next one? Yeah?
I was late, you may have covered this. Could I use these images to provision physical servers?
I guess you could, but this is really more for virtual machines and cloud images. So let's look at the other half of the file. So now we're getting into the provisioners block right here. I'll talk about this later. You could ignore this little chef stuff. I'm not actually using it, but it's a part of the template engines or the repository I use to make a lot of these. But here's the command it actually runs to when it runs these scripts. So it literally runs those commands and runs the bash script. So it copies the file in here. So this is what it looks like on the file system. And so I have, this basically sets my mirrors up to me locally. It fixes some DNS issues. It sets up SSHD the way I want it. I don't need to run this, but it does it anyways. It does that's where it installs the, the VirtualBox stuff, which I'm not going to use, and go forth. And then I made this special script, OpenStack, which installs all the OpenStack goodies I need to make it boot up on OpenStack. And the provisioner I'm using is Shell. Now here's where you could also set up using Chef. You can use Ansible. There's others that you can use, but in this case I'm just using Shell because it's the easiest thing. And then down here are variables that I'm actually setting. You can set them on the command line, but here I'm literally setting it. So it's not going to install Chef, and I'm using my own mirror for installing it. So this is about the simplest Packer template file you can have, at least for QEMU. So here's just what it would look like if you ran it on the command line really quick. I didn't let it run through the whole thing, but you run it, it does its stuff, it downloads the ISO, does all the magic things, it starts the HTTP server up. Since it's QEMU, it has to do port forwarding by default, so it knows how to do that. And it also sets up the VNC port. And so it boots it up, it does its magic. And then technically after here, it would show the output of the commands you run and those scripts. And then at the very end, it makes the image. Really simple. Any questions? Okay. So it has a few command line tools towards it. I've already showed you build command. That actually builds the VM. You can run the expect command. And it basically kind of gives you a quick overview of what's in the Packer template that you might want to know. So in this case, it shows the variables, it shows that it only uses the QEMU builder, and it's using the shell provisioner. That's kind of useful. To help with making sure you're doing things proper in JSON, because JSON can be annoying sometimes, it has a nice little validate command. The validate command also checks for Packer configuration specifics. So it ensures that you're doing things the correct way for Packer itself, not only checking JSON validation. By default, if you've already created an image in the output directory, it won't create a new one. It'll say, this output directory still exists. There's an option to tell it, I don't care, make a new one, and start from scratch. So I was looking on the docs, and apparently they added a new command called Packer fix. And essentially what that does is, as Packer evolves and new features are added, they change the configuration file format a little bit. It'll do those fixes for you. So you can say Packer fix template file, output it to a new file, and now you have an updated file that has all the fixes that Packer has. So it's really, really nice. It also has machine readable output for about any command that you use. So in this case, when I'm doing the expect command, it just prints it out basically as a common separated output. So it makes it a lot easier to manage with scripts and so forth. So it's pretty handy. So let's talk a little bit more about builders. So that is responsible for creating the images. So it can be QEMU, VirtualBox, EC2. There's a builder definition, which is maps to exactly one build. However, you can have multiple builder definitions for the same builder. So like I said before, you can have one QEMU builder that makes one type of QEMU image that you have, and you can make another one that's a little bit different. Typically, you would have a Packer template file for each operating system. You don't want to put multiple operating systems in the same Packer file. You can't really do that. That unique name isn't really needed, and I think I actually had that in my slide. But if you're doing multiple builder definitions, you do need to have that so that it knows how to use that. Here's still the list of all the builders that Packer currently supports. It's an open source project on GitHub. If you know Go, you can contribute. I know when it didn't have QEMU initially, actually someone else created a fork and pull request, created the basic QEMU support, and actually help beta test some of those features. And it's a great open source project. So works out really well. Yeah. 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 I have another slide, a couple down, to maybe explain a little bit more about that. So, as I showed you a lot of examples with QEMU. I honestly haven't used it other than VirtualBox and QEMU, but I know it works with a lot of the cloud providers. So here's an example. I've taken a lot of this text literally from the documentation site. So in the case of Amazon, there's literally 3 sub-builder types. So you can do it via EBS, you can use their Amazon instance, or you can use the chroot method of doing that. From what I understand, the EBS one is what people should start out with. If you really want to do hardcore and awesome stuff and make things really fast, the chroot method is really probably the way to go. Then we get into the Docker stuff, and I wish I had time to actually try this, but from what I understand, it builds the image without the use of a Docker file. That provides it to have the ability to kind of keep things portable between all the various builds that you're doing. You don't have to have everything tied to Docker itself. It allows you to use the same tools that Packer already knows about with provisioning. So if you want to use Chef or Ansible to build out your containers, you can do that. It basically uses Docker to make the image. So you have to have Docker on the system you're running this on, and it does that. There's a lot of post-processors that I've added to deal with Docker, so you can literally run Packer and it'll register it into the Docker registry. Or you can have it automatically add to your local Docker and everything. Like I said, I wish I had time to do that, but I'm assuming it's going pretty well if they have that in there. So now we're getting into provisioners. I've already showed you shell. You can either do shell scripts or inline for simple things. You can also do simple file uploads. And typically what you do that for is maybe you have a tarball that you want to upload that you have in your repository. You can have that, and then you can move the files inside of the image. I haven't really used it that much, only with scripts sometimes. You can also do Ansible provisioning using the playbook and role files if you wanted to. You can do Chef Client and Chef Solo. So in the case of Chef Client, it'll configure it to talk to a Chef server and provision it if you wanted to. Or you can run Chef Solo, and you can point it to some local cookbooks, or you can upload them literally on the VM while it's building. So that's great if you want to make a base image that has your base cookbook with everything kind of built out. You can run Puppet masterless, so you can just basically run Puppet apply, have some local manifests and modules to run things if you want to. You can also have Puppet server, so you can connect to a Puppet server and provision it that way and create an image based off of that. And it also has support for Salt. And I guess it uses salt states. I don't really know Salt that much, but from what I understand, that's how it does it. If your configuration management or tool isn't up there, it's pretty easy to make a new one if you know Go. So there's a community out there for that. Now we're getting into the post processors. So There's compress, which it's mostly used for VirtualBox image and VMware. For example, with making a Vagrant box, it needs to use the compress to make the .box file format, so it does that. And then Docker has 4 different post processors, so you can enable the Docker import to import it locally. You can push the image to the Docker repository. You can save the Docker image directly to a tar file if you wanted to, or you can also tag the build in the Docker repository itself. I'm not going to go into the details of all those options, but the documentation on the site will kind of go through all of that. There's a Vagrant post processor that also makes it into the Vagrant box. And HashiCorp, which is Mitchell's company behind all of this, I guess they have a Vagrant cloud where he can host your Vagrant images if you wanted to. So they have a post processor that'll push to their cloud image hosting if they wanted to. And then it also has vSphere support for uploading to that. So, and again, if there's a post processor you want to create, it's extensible. You can do that. And speaking of extending Packer, it heavily uses a plug-in system. So much so that all those builders, provisioners, and post processors are actually plugins themselves. They're not part of a core part of the app. So if you want to add on to Packer, it's pretty easy. So if you're interested in doing that, check out their docs. It's quite extensive. So there's a lot of other Packer tools that are out there. Before I get into that, are there any questions? I'm kind of going through this really quickly. You can. By default, I don't think there is one for that, but that would be really nice to have. Yeah.
Can you base one Packer image off of another, so you've got kind of like if you want sort of a base thing and then build a bunch of other stuff off that?
So can I base one Packer image and build off the other? It depends on the builder tool. So in the case of OpenStack or EC2, you can use this reference image, and then make a new image off of that.
The original AMI.
Yeah, you pull it off the original AMI, and then you make a new one. In the case of QEMU, I don't think you can do that, but the other cloud providers, that's how they all work, basically.
Have you used Packer to change the provider of a Vagrant box? So they'll have them on the cloud that they're using for VirtualBox, not for VMware. So if you use this maybe to change the provider without changing the actual image.
I think so. So you're saying you want to make one for VMware?
Yeah, just change the provider out.
Yeah, and actually, that's one of the things I was going to mention next is a tool that or a project that's kind of done that. But I'll get to that here in a second. Very manual right now, unfortunately. We haven't gotten that far in our automation process. But my goal is to integrate it more into Glance. So, if I had time to make the post processor, I would do that, but I'm probably honestly just going to put it into a Jenkins job that just runs Glance on the command line on the node and upload it that way. So that's kind of how I was going to do it. Yeah?
For the shell provisioner, is there any way to execute something locally on the box in Packer versus on the...
Can you run a command outside of the VM? I don't think Packer's designed to do that. Typically, that's something you do outside of Packer. So can you give an example of what you would want to do that with? Oh, Capistrano. Yeah. Well, that's literally, you do an inline command. Well, the inline command works inside of it, so no. There's probably a way, but I don't know off the top of my head. I'm sorry about that. Yeah. Well, I'll go on to the next topic. So, Bento. It's a project out of Chef, and basically, how many of you use Chef in here? A lot of you. How many of you use Test Kitchen with Chef? Okay. Anytime you download a VM image from Test Kitchen, it's used from Bento. Bento is basically a Git repository full of Packer templates, scripts, and other tools for building images for a lot of different operating systems. And let me go to that website real quick, and I'll just give you an example of what it looks like, just to give you some idea. So it has all of these operating systems that you can have that they've already figured out how to build, basically. And it has all the scripts you ever needed to know to build the various operating systems. It looks like they're doing Windows stuff. I've never used it, so I don't know how they do it. But it's really, really cool. So when I first started doing Packer stuff, I created our own Packer repository called Packer Templates. And it was great because I basically copied what I've been doing internally with Vagrant building. And then I kept running into weird problems. And then I found out about Bento, and I was like, I'm just replicating what they're doing. I should just fork what they're doing and kind of help with this project itself. So one thing to note, by default, that Bento repository is primarily for Vagrant boxes, but I've modified, checked out our own fork to make OpenStack builders for QEMU. I'm going to try and talk with them to see if I can kind of get it integrated in the repository, because I imagine a lot of people would be interested in this. I haven't had the time to do that. So for me, I liked it because it covered most of the platforms I care about. They've already done the hard work for the weird things, for the most part. Like, I need to do this little tweak on this version of this operating system, and so forth. And it's also a great place to look at a lot of examples of, like, well, oh, this is how I can do this with Packer. Or this is a cool thing I can do. I actually learned a little bit looking into that. So in our fork, we have some OpenStack builders for Ubuntu, Debian, CentOS, and Fedora right now. But it's a really cool project. So definitely take a look at that. So demo time. Any questions before I get into demo time and see how well my demo works? All right, let's see how well this works. So I'm going to start building, oh, go ahead. How does it connect with the AWS? So from what I understand, you base it off of an AMI image you want to base it off of, and it builds that, and then it may upload it to S3 or it saves it in there. You have to give it the API key of your account to basically do it. So it does it that way. So that doesn't run locally. It does it all in Amazon Cloud. I'm going to show you an example with QEMU, which is what I use quite a bit. So I'm in my own Packer build area. I'm going to run Packer. I'm running this locally on my laptop just so you can see the coolness of the VNC stuff. I'm going to switch to a remote server to do the full install because, you know, I don't want to do all the network stuff here. But I can only look it over VNC, and the VNC won't let me look at the typing part because it's connected to the VNC. So I can't look at it. But I want to at least show you that. So I'm going to do a CentOS 7 build. I've already downloaded the ISO. So it's doing its magic. My hands are above. I'm not touching the keyboard. No hands. No hands, Mom. So you see it's waiting for SSH. I never did set the size of the screen, so it made it huge. So it's booting up, and it's starting the installer. So I want to at least show you that much. Let me flip over to my server that is a little bit more powerful and do the same thing. And I have this set on headless mode, so you can't actually see it. Oh, I already have Packer in here. So I'll let this run. And I can actually connect to that really quick. Oh, wait. What is it? 47. I always get it wrong. Oh. Oh, well. Oh, it's still typing. Yeah. So, we'll watch this actually boot up. So now this is connected over VNC. While this is going up, are there any questions? Yeah? Yeah.
I'm trying to understand, why you have multiple builders. What is that?
Well, it's based on what your needs are. So in my case, I want to make QEMU KVM images, so I care about the QEMU builder. In the case of Vagrant with VirtualBox, that's a separate builder. There's separate nuances you need to use to build a VM using that.
So there's not multiple builders in the same file?
There can be, yeah.
There can be. And
Yeah.
And would the provisioners be applied to both of those builders?
So let me show you what their how they actually do it in here. So this is their version that they have. So here they have a builder. This is VirtualBox. And then down here is another one. This is using VMware. So it's in the same file. So you can see type VMware ISO. And then down here, they have their parallels builder. So they have all the various settings for each of them down here. They have different settings. And then here it's doing some post-processor stuff. So this is doing the Vagrant post-processor. Here's the shell post-processor. That basically every one of those gets this run as well. And then it sets the variables. So this is their CentOS 7 configuration file. Does that make sense? Yeah. So kind of looking around in here, in the case of CentOS 7, I just have my Kickstart thing in here, and it's just very basic. I do the very minimal amount to get it going, and I do the rest in the scripts. So I've copied a lot of what they did with their Vagrant builds, but I've kind of taken things out which I don't want. In the case of OpenStack, when it boots up, it uses CloudIn. How many of you have heard of CloudIn before? So a few of you. So CloudIn is a service that when the VM boots up on OpenStack, it listens to a metadata server, and the metadata server will say, hey, you need to set these things up. So that's how it gets the SSH key to you. It sets the password, and it gets DHCP going so that the VM gets all set up automatically, and it scrambles the passwords and all of that. So that's kind of why I don't care about the passwords on this particular image. And then in the scripts, I kind of have things separated out. So in the case of CentOS, I have my OpenStack script, which installs all the stuff that I need to do. Based on Grub, you know, I want to have Grub serial console going out so that when it boots up an OpenStack, I can go to the console that shows all the output. And then I make sure that there's some fixes I need to deal with on systemd, because systemd, making sure that CloudIn starts up and everything before SSH. We had problems with Test Kitchen, basically, where it would fail because it couldn't connect to SSH because CloudIn started after SSH, and CloudIn gets the SSH key put in first. So this is the workaround for it. So I'm going through here, almost done. Yeah.
This is the file, each builder you're sort of saying, I want to create a CentOS image for these different cloud providers.
Yep. Yep.
And the provisioning is like after those images are created, they're spun up, and then I either run the script or check whatever that they match.
Yep. 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 That's basically how it works. So the builder gets the basic OS going, and then the provisioner does any of the magic that you want to do afterwards. So it can be as simple as putting in just a couple of files and that's it, or you can do a full-blown base image that has everything pre-installed that you want to have.
And when it creates the final images, stored locally, or is there?
In the case of QEMU, it's locally. In the case of the cloud providers, I think it does the commands through the API that saves them that way. They've added OpenStack support, which I haven't tried using yet. When they first had it, it only worked on the Rackspace OpenStack cloud. It didn't really work for private OpenStack clouds yet. I think he finally fixed that. But it does the same thing. So it takes an image that you use, and then it does its magic. You don't have to do all the QEMU stuff here. I'm doing it from scratch because I want to know exactly what I have in my image. And then it says make a new snapshot, or it makes a new image in Glance, and it does all that. I think that's how it works. Let's see here, where am I at? Any other questions? Hopefully this actually finishes. Yeah, I still have an active session. Yes? It doesn't run any tests by default, but there's nothing stopping you from writing your own tests. So after Packer builds, you can do your own stuff, basically. Or you can build that into your post-install scripts if you wanted to. Yeah?
Is there a JSON filter tool?
Not really. You just kind of have to make the file by hand or look at some examples and kind of go from there. The Packer documentation has quite a good set of examples. Shouldn't be taking this long. This is one of my newer builds. I probably should have done CentOS 6 since I know that works. Let me flip that really quick. Even though I'm running out of time. All right. See if this goes a little bit faster. With this being a Go application, the installation for Packer is a little strange, at least for me, for myself. Basically, you download a zip file, and you just, because all the binaries are just basically big, gigantic binaries, you put them in a path that you can run from, and there you go. You don't have to install anything else. You just download and unzip it, put it in a path that you can run from, and it just goes. Whoops. I know this one should work. Go ahead.
Let's say I'm installing a basic image of Debian and I want to install, let's say, PostScript on it.
Mm-hmm.
Sometimes that will bring up the UI asking for like the host name and the smartphone.
Mm-hmm.
Do I use the same command that you use just to key in stuff, or?
In the case of Debian, you have to do that in the pre-seed file. So with Debian, you have to basically create answer files that answer the questions that the installer would want to know answers to. With Debian, it's a little harder to do, but that's how you do it. You don't do it from Packer itself, but you do it with the Kickstart that way. Or, I guess the other way is when you run apt-get install, I think you can tell it an answers file. So you can upload the answers file and then run apt-get install, and then it answers it all for you. So that way you don't have it interactive. And I think you can also set, I think apt-get by default, if it knows it's in a non-interactive prompt, it won't do some of those questions, I think. It might take the defaults or something like that. But I think that was how it would work. Something else I was going to mention, before we've done stuff with OpenStack, we've done a lot with Genneti. How many of you have heard of Genneti before? Cool. So Genneti is awesome, but it's more for your pet VMs than your cattle VMs. It's a project by Google, and it's basically an infrastructure as a service platform. It's a heck of a lot simpler than OpenStack. But dealing with images on Genneti can be problematic somewhat too. And so I've started experimenting with Packer to make Genneti images. It's basically the same process, except I don't need CloudIn, at least not yet. So I'm exploring around doing that as well. So if you're interested in that, check out our Bento fork, and you might see some stuff going on with that. I've been experimenting it with the SNS image instance provider with Genneti, and it basically does the same thing that OpenStack does, basically, and it seems to work pretty well. And this should finish within my time slot. Something else that I've done, or that Bento has done in these, is to actually minimize the disk images. One of the scripts it runs is zero out, or cleanup. It literally runs dd with dev0 and puts it into a file, runs sync, and so it fills up the whole disk, but it fills it up with zeros and clears it out. I really would like to make a post-processor for Packer that after you do that, you run the QEMU image convert command on the same file, and it takes that, because when you do that, you fill up the whole global disk, basically. So that's why I make a 2 gig disk. And then when I do this, this image turns into, you know, a 230 meg file, which is nice and easy to deal with.
How do you spell
G-A-N-E-T-I. And you'll probably find a lot of my slides and presentations if you look it up. I've done several presentations in the past about Genneti. There we go, finally. This is running on a system back in Oregon.
Is there other stuff out there comparable to Packer?
Yes and no. I don't think there's anything out there that covers as many different platforms with the same tool. A lot of them are either made for just OpenStack or for other things. I think there might be some others out there. Since this was a fairly new project, I really latched onto it because it solved a lot of my problems. So now it's installing all the packages I need for CloudIn and OpenStack, which is a whole bunch, unfortunately. And you can turn off the color output if you want. By default, it makes it colorized. And when you do the multiple builders, you can tell it to do parallel builds. By default, it doesn't do parallel builds, but you can tell it to do a whole bunch of those builders all at once. A quantity? Well, this is for making one image that you deploy. Yeah, this is making the single image that you're going to use other places. So if you want to make a simple instance, this isn't deploying the machine itself. This is making the golden image that you want to have that you're going to deploy everything on. So the nice thing about this is a new version of CentOS or whatever comes out, I update my Packer templates, I kick off my Jenkins build, it pushes it up to my cloud, I test it, it works, done.
So if you've got provisioning happening in Debian, right, let's say for devs or whatnot, you want to push over that to an image to push out the cloud or whatnot, would you take that provisioning and put that in Packer in order to provision the image?
You could. I don't know if that's a good way of doing it, though.
What would be the alternative?
So you're saying you want to take...
So you build out like a good image that you can run in Debian, and then you want to, so you've got that image and build everything happy, but you want to push that, you want to pack that up into that image and shove it out into production. What would be the way to do the provisioning at the end of the image creation?
So where is your production living? Is it in AWS? So in Packer, what you would do is you would basically write scripts that does the same thing for getting that, or configuration management or whatever to make that, but then you have a separate builder that does it in Amazon, and it just uses the same set of scripts or configuration management tools. See, that's the nice thing about Packer. You have one configuration file, you just add another builder, and it does the same thing for that other builder. So that's the nice thing. Like I make the image that works on Vagrant, but then I make the same image that I want to have in the cloud. Yeah, that's the beauty of Packer. And now it's running its minimize command. And I think it should be done, basically. It should be done. Here we go. Now it's turning off the VM. And I have a QEMU image file in there. Cool. Any other questions? Oops. Wrong button. Mm-hmm. Well, I actually have a script that makes it handy. I can't remember the exact command. I literally added it in here. So QEMU image convert. Well, let me just copy paste this. I have to set the compatibility version because this is running on a CentOS 7 machine, and the version of QEMU on CentOS 6 is too old for Packer. But my nodes on CentOS or on my OpenStack are running CentOS 6, and if I didn't tell it to use this compatibility version, the images wouldn't work on the CentOS node, so I had to tell it that. And so here I'm telling it I want the output to be kickout2, compress it is -C, so I'm going to take this image, CentOS 7, 6, that file, and then I'm going to output it to basically the same file, but I'm going to give it to compressed. And that's just a nice little thing you can do with, QEMU image command. You can convert it into other file formats. And so it's essentially doing it's recreating a new KQCal file, but it's compressing it down. So all those bits that you put zeros on are now duplicated, and it's not filling out the whole thing. So here it's recompressing it. But anyways, I'm over. So if you have any other questions, let me know. I'll be around at least for another hour, and then I got to catch my flight. Thanks.
Slides when you're available?
Huh?
Slides when you're available?
Yeah. Yeah.
Yeah, post them online or?
It'll be on the Scale site, and then it's actually also on my GitHub.